Okay, word problems. All right, the first example, I'm actually just going to write it down. It's quite a short one. You don't have to write it down. It is there on that page. They say the product of two numbers is 135. Let's remember that product is when you're multiplying two numbers together. All right, so it's saying one number multiplied by the other one is 135, and the difference is 6. And they are asking us to determine the two numbers. Now guys, sometimes with these types of questions, you can kind of do it by section. So usually in a test or exam, they will say set up an equation in order to find the two numbers, right? So they'll tell you that you can't just figure out which two numbers. If I multiply them, it will give me 135, and if I take one minus the other one, I'll get 6. So you can't just write an answer. Okay, you would have to do the whole equation. 5 to determine the two numbers. Now guys, if you read through the left-hand side of this page that I have it out, you would have seen that the second bullet there is just saying, let the quantity you are required to determine be equal to x or any other variable. You don't always have to work with x, it's just usually the one that we work with. You may also be able to express some other quantity in the question in terms of it. So that means that if they're telling you, for example, the length is twice the breadth, all right, then you can say that the breadth is x and the length is 2x. All right, if they're telling you that there's some kind of relationship between two different things in the question, then you can actually use the same variable to express them. We'll see in the next example. We're going to do that. Okay, they're just saying here the product of two numbers is 135 and the difference is 6. Determine the two numbers. Now guys, we have two options here, all right? We can actually work with two variables. We can work with an x and a y, right? Because they're telling us that we're working with two numbers. So let's do that. Let's say, let numbers or the two numbers, whatever you want to say, be equal to x and y. Now we can use that to actually write equations for the two parts of information that they've given us. So we agree that they've given us two parts of information. They've told us something about the product of the numbers, and then separately they're saying that their difference is 6. All right, so the product of the numbers, that means that they're multiplying. So therefore, x times y, we can write as xy, right? So one number multiplied by the other one will be 135. That's from the first bit of information. And from the second bit of information, guys, the difference is 6. So if we take one number and we minus the other one from it, it's 6. Okay, now here it doesn't really matter. They're not telling us which one is bigger. Okay, so we can say x minus y is 6. Or you can say y minus x. One actually matters. So I actually just want to, let's just do some highlighting here, just to show that this equation is coming from that bit of information. And then the second equation is coming from the second bit of it. Now guys, if we're just looking at those two equations that we have, do we notice that we have two equations with two variables? So what do we have to do there? Well, then simultaneous is good. All right, so we're going to have to use simultaneous equations. I'm going to write on the side, we have two equations with two variables. Therefore, solve simultaneously. So they are asking us for both numbers, right? They're asking us to determine the two numbers. So if we say that the one number is x and the other one is y, we now need to find x and y. Okay, so we need to solve them simultaneously. Guys, we've done lots of practice with simultaneous equations, right? We need to look at the two equations that we have. We need to identify in which equation will it be the easiest to isolate one of the variables. Okay, I'm not going to use the first equation for that because if I want to make x the subject here, if I want to isolate x, I'm going to have to do 135 divided by y. And then I'm adding a fraction into it. Okay, which we should try and avoid. So if we're looking at this one here, it will be easy to make x the subject here, right? We just move that minus y over. Okay, so I'm going to do it here. I'm going to say x is equal to negative y is going to become positive y. Now you can write it as 6 plus y or y plus 6. I think 6 plus y is also fine. And remember, once we've done that, we now need to substitute or replace the x in the other equation with a y plus 6. Okay, so this x over here, I'm now going to write as y plus 6. And that is times y is equal to 155. So guys, this has come up a couple of times where the y or the number or whatever is after the bracket, which is a bit strange. So you are allowed to just rewrite it like this if it makes you feel more comfortable. Right? You can just put the y in front of the bracket instead of behind the bracket. And now it's easy to see that we have to multiply that y in, right? We're going to say y times y is y squared. Y times 6 is 6y. And what type of equation is this now, guys? Quadratic. So we need to move the 135 over, right? We need to identify it as a quadratic equation so that we know that we must move the 135 over. Because remember, we must get it in standard form. Okay, now this is quite a difficult one to factorize anyway, because it's a big number here, right? So let's use the quadratic formula. We're going to say, now not x, right? We have to use the variable that is in the equation that we got. So we have to say y equals, what is my b value here? 6. So I'm going to say negative b, right? So negative 6 plus or minus the square root of b squared. So 6 squared minus 4a, which is 1, times c, which is negative 155. That's very important. And that is then all over 2a, which is 2 times 1. Okay, I'll type that in and give everyone a chance to do it as well. Okay, so I'm getting 9 for my first answer. And then for my next one, I'm getting negative 15. Okay, now guys, we need to now use both of these y values to get two x values, right? And then we're going to have to check afterwards whether they actually work. So if if y is 9, how am I going to find what x is? Substitute it back into this. Hey, when we made x the subject, this is telling us x is equal to whatever 9 is plus 6. Sorry, whatever y is, but plus 6. All right, so in this case, y is 9. So we're going to say that x is 9 plus 6, right? Y plus 6. And that is 15, right? Now, guys, does that work? Check quickly. What is 9 times 15? 135, right? They say the product of the two numbers must be 135. So if you take 9 times 15, it does give you 135. And then what's the other bit of information that they say? The difference between the numbers is 6. Now, like that is true, right? The difference between 9 and 15 is 6. Right? 15 minus 9 is 6. So that does work. Okay. Or if y is now the other number, negative 15, we need to check what is the x value that goes with that one. Then x is going to be negative 15 plus 6, which is negative 9. Yeah, and that also works, right? If you take negative 15 times negative 9, it will give you positive 1.5. And the difference between negative 15 and negative 9 again is just 6. So guys, in this question, it looks like quite a simple word problem, and I don't think it's too difficult to set up these things here, right? Xy equals 135 and x minus y equals 6. We just use the 2 bits of information that they gave us to set up those equations. After that, it's a simultaneous equation which we've practiced. It's a quadratic equation which we've practiced. Okay, so we are now using the different types of equations that we've done so far in a word problem. Okay, see how much time is left. I actually want you guys to try one that's similar to this one first before I do another type. And so the second example is a different type of example. Just check. Maybe you guys can do this in class and we can mark it and then we don't have one more over the screen. And then maybe you can spend some time on your just throw it out there. You can really want that now. And just vision exercise maybe. Yes, okay, now guys, this one is slightly different. So I'll just read through it with you, revision. On page, the exercise starts on page 44, but the question is on page 45. I want you to do number 10. And I'm actually going to write the question down so that I can just make some notes here. So we'll say the sum of two numbers is 40. And the sum of the squares is 818. Determine the two numbers. Okay, so it's very similar to the one that we just did, but the information that they're giving us is different. Okay? But again, you see, we're going to work with an x and a y, right? The two numbers, and they're giving us two parts of info, two pieces of information of these two numbers, about these two numbers. So they're saying that the sum of two numbers is 40. So I want you to start this question in the same way. Just write, let the numbers be equal to x and y, right? Now guys, if they're saying the sum of two numbers, what is that? How do you get the sum of two numbers? By adding it, right? So the sum of two numbers is 40. That's going to be x plus y equals 40, right? Two numbers, you're summing them, you're adding them together, and that gives you 40. Okay, now they're saying, and the sum of, so again, we must add stuff, right? Of their squares is 818. Now, how do you get the square of a number of anything? You just square it, right? You multiply it by itself. So if the one number is x, what is the square of x going to be? X squared, right? And the square of y is going to be y squared. Okay, so they're saying that the sum of these two numbers, x plus y, is 40. Are we fine with that? That's the first bit of information there. I'll highlight it again so that you can see. Sum of two numbers is 40, and that is how we translate it into an equation, right? One number plus another one is 40, and then they are saying the sum of their squares is 818. So the square of x is x squared. We're saying sum, so we must add. The square of y is y squared, and that they are telling us is 818. Sum of the squares is 818. Again, we have two equations with two variables. So please solve these two equations simultaneously. But which one are you going to choose to isolate a variable? The first one, hey, please don't try and isolate those variables if there's a square involved, okay? So choose either x or y on the one in the left, and then sub that into the other one. Yeah, so finish that one now, okay, then we can mark it. Okay, so guys, we have x is 40 minus y. Then we replace the x in the other equation, right? With 40 minus 1. But the whole thing we have to square. That's important. Guys, I'm worried that you are just squaring the first one and the last one when you have the bracket squared. Okay, that's a 0 automatically if you do that. That's a very bad error. So whenever you have a bracket squared, you have to write it as two separate brackets and FOIL those out. Okay, you have to do that, please. So you're going to say 40 times 40 is 1,600. 40 times negative y is negative 40y. Then you have negative y times 40, which is the same thing. Again, negative 40y. And then we do negative y times negative y is plus y squared. So this whole thing here is these four terms. Right? But then after these two brackets, we still had another plus y squared, which you must remember to add in. Okay. So you're multiplying out, you're getting those four terms, then there's another plus y squared equal to 818. And then you need to collect like terms. So you're going to have y squared plus y squared is 2y squared. Negative 40y minus 40y is negative 80y. And then here you're going to have 1,600, but then this 818, when you bring it across, it's going to become negative 818. So 1,600 minus 818 will give you 782. And then that is equal to 0. Then you need to put all of that into the quadratic formula, work it out, and you will get two answers for y. 23 or 17. Now guys, when you take those two answers, the 23 and the 17, and you put it back into this, okay? Because now when we found y, we now need to get x. So x is 40 minus whatever your y value is. But guys, if you see that when y is 23, then x is 17. But then when y is 17, x is 23. Okay, so just quickly, guys, are you seeing that we're getting the same two numbers in both cases? Right here. That just means that those are the only two numbers that will have both of those relationships. But if we add them together, you're going to get 14. And when you say 10 squared plus 17 squared, you're getting 1. All right, so we only have one pair of answers. All right, so we need to write it out like that. And then that is the answer. Okay, guys, please spend some time this weekend working on your projects. I have not given you homework.